Hi everyone, in this video I will show you how to run our Dual-HINet code. Dual-HINet is for estimating a connectional brain template that is aware of graph structure for a given population of brain multigraphs. This work has been accepted at MICCAI 2022 Singapore conference. First, we will start with creating a Conda virtual environment. Then we will see how to install needed packages. At the end, I will show you the input and output data representation and the execution of the code. You can download Anaconda from the following website. Download the latest Python 3 version for your system. For our project, I've used Python 3.8 for 64-bit Windows. The graphical installer will walk you through the process. After the installation is done, from the Anaconda prompt, create a Conda environment by typing the following command. Use the Conda activate Dual-HINet command to activate your environment before installing any dependencies. To install, copy and paste the following commands, which you can find in our GitHub. If you have any problems, PyTorch Geometrics installation tutorial can be helpful. Finally, download or clone Dual-HINet code from this GitHub link. Our method takes in a dataset of multigraph subjects that are stacked symmetrical adjacency matrices. The first dimension of the input is number of subjects. The second and third dimensions are number of ROIs, region of interest. The fourth dimension is the number of graphs of the subject. The model outputs a CBT, a single graph, which represents the average connectivity between ROIs of the brain network population. The code components are as follows. Helper.py is where functions that process and simulate data exist. Dual-HINet.py is where models are trained and cross-validated. Config.py stores hyperparameters. Simulating data or using an external dataset path is done here as well. You may modify it as you like. Demo.py is for executing the code. GNN.py includes the GNN model classes. Now, let's see an example of running the code. And that's about it. For more information, please visit our website, YouTube channel, or GitHub repository.